Good afternoon, class. We are looking at chapter 3, derivatives. The first section, 3.1, derivatives and rates of change. We're going to look at that one, then the next section, the derivative as a function, basic differentiation formulas, the product and quotient rules, the chain rule, derivatives of the log functions, differentials, and the synopsis of what we have covered. The limit of a sub n as n approaches infinity is L. We say it converges to L. Otherwise, when it's infinity, negative infinity, or doesn't exist, we say it diverges. Then we give the definition of a limit, which simply put, as long as the one-sided limits are identical, the limit does exist. And then when we look at this graph, we notice there are three pieces. In all cases, the limit of f of x as x approaches a exists, and it's equal to L. In this case, f of a is also L. In this case, f of a is the y-coordinate of this dot, and in this case, f of a is not given, and therefore it gives rise to the definition of a continuity, which pertains to the first one. If the limit of f of x as x approaches a exists, and it's equal to f of a, then the function is continuous at a. Also, we looked at VA and HA. VA stands for vertical asymptote. When we take a limit as x approaches either a from the left or a from the right, and the result is infinity or negative infinity, x equals a is the VA, vertical asymptote. If we take a limit as x approaches negative infinity or positive infinity, and it gives us a result such as L, then the line y equals L is the horizontal asymptote. And now the new stuff, if 2 points are given, everybody knows how to calculate the slope. When we have 2 points on a curve, we can connect them. The corresponding line is called the secant line. How do you calculate the slope? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, if you look at this one, the first point has coordinates a and f of a. The second one, x and f of x. So if you go with that, it gives you this definition. F of x minus f of a over x minus a is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you look at this one, where the first point has coordinates a and f of a, and then this distance is h, therefore this becomes a plus h, and q has coordinates a plus h and f of a plus h, gives you this definition. So this one versus this one is just a matter of how you look at it. If we call this point B, then this has coordinates B and f of B, in which case gives you this definition. All of them refer to what we call a difference quotient, and it's rise over run. So those are secant lines. Now, we are interested in finding the tangent line at point P. So the tangent line is the limiting position of the secant line PQ as Q approaches P. If we have this secant line and then move it closer, closer, and closer to P, then we get closer and closer to the tangent line, in which case the slope of a tangent line, or the instantaneous rate of change, is defined as follows. M of tangent line is the limit of M of a PQ, the line PQ, as Q approaches P. Q approaches P. Or if we go with this definition, limit of f of x minus f of a over x minus a as x approaches a. So here's x, and it's approaching a. If we go with this definition, the limit of f of a plus h minus f of a over h as h approaches 0, as this distance becomes 0. All of them are giving us the same. And I hope you remember the point slope formula. From elementary algebra, y minus y1, y minus y sub 1 equals m times x minus x sub 1. In this case, y sub 1 is f of a. You're looking at this pair. You're looking at this pair. Okay. A and f of a. So y sub 1 is f of a. M is f prime of a, and x sub 1 is a. It's the same thing. You don't have to really memorize much. And so f prime of a, which represents the slope of a tangent line at a, has one of these formulas. We should be comfortable with both, and we use both of them from time to time. Ultimately, you normally use the second one. So the synopsis of what we just covered. The difference quotient, or just the slope, rise over run, delta y over delta x, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So if you look at this graph, we call this x sub 1, therefore this becomes f of x sub 1. We may call this a, becomes f of a. This distance is delta x, x sub 2 f of x sub 2, or you can call this distance h, depending upon what text you use, what formula. This is called the average rate of change of y with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line, PQ. So this line has a slope and its rise over run. We recognize the following limit as being the derivative f prime at x sub 1. So if we take the limit of delta y over delta x as delta x goes to 0, we make this distance, which is the same as h. If we make this distance go to 0, if we go with this definition, f of x minus f of a, remember what this is. In this case, we call this one a. This is x. Then we have the limit of f of x minus f of a over x minus a as x approaches a. If we stick with what we see here, we have this definition. The limit of f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 as x sub 2 approaches x sub 1, x sub 2 approaches x sub 1. That means we get closer and closer to the red line, which is the tangent line at the first point. If we call this a and this distance h, we get to this definition, because now this is a plus h. The limit of f of a plus h minus f of a over h as h approaches 0. So we are repeating the same concept. So the derivative f prime of a is the instantaneous rate of change of y equals f of x with respect to x when x equals a, and again f prime of a as we had it in the previous page. Let's make some sense out of this by looking at a couple of simple examples. First and foremost, I want to go back to elementary algebra, and I want to find the average rate of change of this function f of x equals x squared minus 3x as we go from 2 to 4. Whenever 2 points are given, even if they don't mention average rate, it means average rate, which is simply put rise over run. F of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. F of b minus f of a over b minus a. F of x minus f of a over x minus a. Any of them you look at makes no difference. So the first part is just elementary algebra. So the top is the change in y, f of 4 minus f of 2. And the bottom is change in x, 4 minus 2. And so at this point, you plug in 4 and you plug in 2 to evaluate the top as follows. (16 minus 12, 4 minus 6 becomes minus -2, and they add up to 6/3, 6/2, which gives us 3. So that's elementary algebra, not a big deal. The second one, we are given only 1 point, and that's the key. 1 point means instantaneous, even if they don't write instantaneous. The moment you hear rate, it depends whether 1 point or 2 points are given. 1 point means instantaneous, 2 points means average. So we use either this formula or this formula. So if we stick with the second one, which is used more often, A is a 4. A is 4. So f prime of A becomes f prime of 4. Limit as h approaches 0 of f of A plus h becomes f of 4 plus h, minus f of A becomes f of 4 over h. Now, everything is algebra until the last point. We are going to plug in 4 plus h into this function, and we're going to put 4 into this function. Now, for this one, you can plug in and observe, or you can use the fact this ended up being 4. Either way is fine. If you remember this is 4, since you've done it, you want to use it. That's fine. Now, how do we evaluate this? This is 4 plus h squared minus 3 times 4 plus h minus f of 4. I'm assuming everybody knows the simple algebra behind this. We are evaluating the function at 4 plus h. And now all you have to do, raise this to the second power. And you remember a plus b squared is a squared plus 2ab plus b squared, which means 4 squared is 16. 2 times 4 times h is plus 8h plus h squared. We distribute minus 12 minus 3h. And this one, this is 16, this is minus 12. Again, you can say minus 4 or just minus 16 plus. So either way is fine as long as you recognize what's going to happen next, which is 16 cancels out negative 16. Negative 12 cancels out positive 12. Minus 3h and 8h add up to 5h. We factor out the h from the numerator. As you recall, whenever we get to 0 over 0, it is the 0 in the denominator that creates a problem. And right now the h drops, so you're left with 5 plus h. So the limit as h approaches 0 of 5 plus h, now it's time to plug in, and we observe the answer is 5. Notice the lim sign remains all the way to the end, or you can simplify this expression and then put the limit at the end and evaluate. So you can, on this side, you can simplify this expression all the way to get to 5 plus h, and then apply the limit. Now, just for practice, I want to show you the second method, which is using this one, f prime of a, in this case, f prime of 4, is the limit as x approaches a, which is 4, of f of x minus f of a, which is f of 4 over x minus a, which is x minus 4. So I'm going to use this. Just for practice, we don't have to do both. So f of x is x squared minus 3x. F of 4, I'm going to use the fact that we calculated as 4, so I don't want to waste time. And if you plug in, you will get 0 over 0. And you remember the technique is factoring in the case of rational expression. Also, x is approaching 4. You have x minus 4 here, which goes to 0. That's a problem. If you recall, that will help you with the factoring. We should have a factor of x minus 4 at top. In fact, we want two numbers. The product is negative 4. The sum is negative 3. And so we have negative 4 and positive 1. X minus 4 cancels out x minus 4. We end up with the limit as x approaches 4 of x plus 1. And when we replace the x with 4, we get to the same answer, namely 5. Again, we did this for practice. You have to do one of them and one of them. Find an equation of a tangent line to the parabola y equals x squared at a specific point. Please understand, they don't have to give us the pair. All they have to give us is the x coordinate, and then you plug it into the y or f of x coordinate. Remember, this is y or f of x equals x squared. So for example, when x is 1, y is 1 squared or 1. But if x is 5, then the answer is 25. The point being, all we need is the x coordinate. So we want to find the tangent line. We are going to use one of those. And so we find the slope m or f prime of a using one of those formulas. So we're going to use the top formula this time. And a is replaced with 1, the x coordinate of the pair. A is the x coordinate of the pair 1, 1. So we want f prime of 1, we plug in. And at this point, f of x, simply put, is x squared. Let's put it there. This is a squared minus b squared. Remember, 1 is 1 squared or 1 cubed, or you name it. So a minus b, a plus b, the numerator can be factored into the product of x minus 1, x plus 1. When we drop the x minus 1, we get the limit of x plus 1. As x approaches 1, we plug in and we end up with 2. That's all we are looking for, because the rest is elementary algebra. Y minus y1 equals m times x minus x of 1. Again, I remind you, this is the point slope, everybody. So y minus 1 equals 2 times x minus 1. And if you distribute, you get 2x minus 2. Moving that gives you this equation in slope intercept form. Y equals mx plus b. Slope intercept form. And what you can do, assuming your slope is correct here, the pair that belongs to the function y equals x squared also belong to the line y equals 2x minus 1. It should work here. We are done here, but I want to look at the second method because I want to show you practicing with this concept. So We don't have to do that. We just want to practice, which means we are going to replace the A with the X coordinate of the pair. So f of 1 plus h, that means plug it in 1 plus h quantity squared. And then f of 1, you can plug it in or work it out, but it's the same as the y coordinate here. It has been worked out. You have the answer. We went over a plus b quantity squared. So square this one, you get 1 plus 2 times the first times the last is 2h plus h squared. So 1 cancels out the negative 1. We can factor the h from the first two. Cancels out the h in the denominator. And so you have the limit of 2 plus h as h approaches 0. You can replace the h here. And it gives you the same 2 that we found here as we were supposed to. So it's the same. I just used a different method just for practice. Let's find the equation of a tangent line for this curve. F of x is square root of x, and the pair is given as 16 over and 16 comma 4. And again, I want to make sure we understand that they don't have to give us both x and y. If they give us x, that's good enough. Just in case. X was given as 25. Can anybody give me the pair? What pair are they referring to? (25) and what is the y coordinate? 5. Because the square root of x, that means square root of 25 is 5. Just plug in. So we want to find the slope first. We are going to use one of the formulas, and we're going to replace the a with the x coordinate of the given pair, namely 16. So what is f of 16 plus h? Plug it in here, square root of 16 plus h, minus f of 16, you really have two choices. Just use 4, it's given, or write square root of 16 equals 4. Either way is fine. I like to keep it as square root of 16 in case we have something other than that which doesn't come out. Can anybody tell me if you plug in what you get here, right here? What do you get if you plug in? Anyone? If you plug in, what do you get?
0 over 0.
Perfect. I hope you see that just the way it's given, you end up with 0 over 0, which means now it's indeterminate and we have more work. And the technique was multiplication by conjugate. So we're going to multiply by the same thing with the plus sign and divide by it. And when we do that, remember the problem is the 0 in the denominator. We are hoping the h goes away, and therefore we don't touch the bottom. But what happens to the top? You have a minus b times a plus b, which is a squared. That means this comes out as 16 plus h, minus b squared. That means this comes out as 16. And as I mentioned, we don't do anything to the denominator. Positive and negative 16 cancel each other. We end up with the h in the numerator. and the h cancels out. We end up with the 1 in the numerator. Now it's time to replace the h with 0. Square root of 16 is 4. The other one is the same thing. 4 and 4 add up to 8. So this is 1 over 8. And we're going to use y minus y1 equals m times x minus x of 1. And we put the pair. So y minus 4 equals 1 over 8x minus 16. Distribute the 1 over 8. We get 1 over 8 minus 1 over 8x minus 2. We move the negative 4, make it positive 4 on the other side. We add 2 negative 2 and we get positive 2. And this is the final answer. Y equals 1 over 8x plus 2. And again, assuming you trust that this is correct, what you can do to check, put the pair in. When you replace the x with 16, you should get to the same y coordinate, because this point belongs to both the function as well as the tangent line. Now, what I want to do, I want to use this one to calculate the slope, again, just for practice. And so I'm going to replace the f of x with square root of x and f of a with f of 16. So in other words, a is 16. So f of x square root of x, and we know f of 16 is 4, or just plug it in, it doesn't matter. So this is the one that, the top one that we are using. If we plug in, I hope you see that if you plug in, you get 0 over 0. If you plug in, you get 0 over 0. And the technique is the conjugate, multiply by the conjugate of the numerator, which is square root of x plus 4. Also divide by it, because this must be equal to 1. So when you do that, I hope you realize for the top, this comes out as x minus 4 squared, which is 16. And this, we just write it as a product. We never, ever distribute. And so the result is x minus 16 goes away and the numerator becomes 1. And now if you replace the 16, you get 4 and 4, 8. And that's the same slope that we found in the first place. Meaning you're just practicing with a different method. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x equals 6x minus 1/4 x squared. How tall is the sunflower 8 weeks after planting? And as always, any word problem, we should pay attention to units if units are given. So for part A, what do you think we should do? Anybody?
Just plug in.
Perfect. Just plug in number 8. This is elementary algebra. Plug in 8. And of course, for the 8, this is 64. 1/4 of it is 16. 48 minus 16 is 32. And we always answer with proper units. And in this case would be in inches. Part B is also elementary algebra because it's asking for the average rate and it's giving us 2 points in time. So we want rise over run. We want the slope of a secant line. We want f of b minus f of a over b minus a, or f of x of 2 minus f of x of 1 over x of 2 minus x of 1. However you want to put that, simply put, evaluate the function when x is 12 minus evaluate the function when x is 6, which is elementary algebra, and that becomes your numerator. This is 72. This is 144 minus 1/4 of it is 36. This is 36 minus 1/4 of 36. So it's minus 27. And the numerator becomes 9. 9 divided by 6 is 3/2. The units inches per week. This is the average rate of growth. Has got nothing to do with calculus. It's a simple calculation using elementary algebra. However, in this case, they say instantaneous rate of growth. Even if they don't, what you want to pay attention to is that there is 1 point in time given. So if they say find the rate without mentioning average, but they give you 2 points, it means average. If they say find the rate without mentioning instantaneous rate, but they give you 1 point in time, that is the instantaneous. So you have to take f prime of a by one of those methodologies, the limits. Either way is fine. So we're going to stick with limit of f of x minus f of a over x minus a as x approaches a, where a is replaced with 10. So a is 10. So f prime of 10 is limit as x approaches 10, f of x minus f of 10 over x minus 10. So replace the a with 10. That means we are going to write f of x just the way it's given, minus f of 10. So let me again just, so you're going to change this to 10. And with that being the case, so f of x is this minus f of 10, plug in 10. 6 times 10 minus 1/4 10 squared. And the bottom is x minus a or x minus 10. So all we have to do, simplify and see what happens to the numerator. So this is 60. Minus 10 squared is 100. 1/4 of that is 25. 60 minus 25 changes to 35. So we have 6x minus 1/4 x squared minus 35. Notice this is a fraction, therefore we are dealing with a complex fraction. We are going to multiply the top by 4 and the bottom by 4. Let me make it look better. And when we do that, we get rid of the complex fraction. As far as the denominator, you just write it 4 times x minus 10 or x minus 10 times 4. Now let's multiply 4 by 6x. We get 24x. Multiplied by the second piece, we get minus x squared. Minus 35 times 4 is minus 140. So that's what we get. Now, remember what's happening. Most of the time you end up with 0 over 0, and that's what's going to happen here, which means you are going to factor the numerator. In order to factor, I'm going to put this in descending order. That means I'm going to put this first. And I'm going to factor out the negative sign. So when I factor out the negative sign, becomes minus parentheses x squared. This becomes negative 24x. this becomes positive 140. So pay attention to the fact I took the negative sign and I brought minus x squared. First, I made it positive x squared. If you distribute the negative sign, you get the same. Now, remember, x is approaching 10, and that's why the denominator becomes 0. We want two numbers. The product is 140. The sum is negative 24. It should help that there's a factor of x minus 10 here, so there should be a factor of x minus 10 in the numerator, so the numbers are negative 10 and negative 40. So this should help you with that. I can cancel out the x minus 10. This is what I get. When I plug in 10, I hope you realize the numerator becomes negative 4. Negative 4 over 4 is negative 1. And the negative in front makes it positive 1 inch per week. So 1 inch per week. That's the instantaneous rate of growth. What does it mean? It means on week 10 or after week 10. The sunflower is growing at a rate of 1 inch per week, right at that very moment, at that time. That's the difference between instantaneous velocity and an average velocity. The distance in feet of an object from a starting point is given by S of t equals 2t squared minus 5t plus 40, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? This is the average velocity because we have 2 points in time, and the average velocity is just like the slope of a secant line. So S of t sub 2 minus S of t sub 1 over t sub 2 minus t sub 1. In other words, a simple example is you cover 100 miles over the course of 2 hours, your average speed is 50 miles per hour. That's the same concept. It doesn't mean that we've been doing 50 miles per hour at any given time. It's just that we have 2 points in time. So we want the average velocity. So we plug in 4, evaluate S of 4. We plug in 2, evaluate S of 2. That would be the numerator. And then we divide by t sub 2 minus t sub 1, which is 4 minus 2. So it's just a matter of elementary algebra plug-in. I'm going to assume everybody can plug in. So you plug in 4 here, 2 times 4 squared minus 5 times 4 plus 40. Then you plug in 2 times 2 squared minus 5 times 2 plus 40. And it ends up being 52 minus 38 over 2, or 7 feet per second. I'm going to leave that for you to fill in the blanks. In other words, show what's S of 4, show what's S of 2. Okay, S of 4, replace the t with 4. S of 2, replace the t with 2. So show that it's 52 minus 38, come up with the answer. There you have it. And that's elementary algebra. But the next one, when it's asking for the instantaneous velocity, or just more importantly, just gives you 1 point in time, which becomes instantaneous velocity. And now you have calculus. VINS, meaning instantaneous velocity, is the limit of S of A plus H minus S of A over H as H approaches 0. I hope if you go back to f of x and how we found the derivative function f prime of A, we are using the same concept here. So at this point, we are going to use the same formula where A is 4. So A is 4, everybody. So S of 4 plus H minus S of 4 over H. Therefore, we are going to use this formula. We're going to put 4 plus H. We're going to put 4. And by the way, 4 is already calculated as 52, or just plug in, either way is fine. So S of 4 plus H, 2 times 4 plus H quantity squared, minus 5 times 4 plus H, plus 4D, minus, if we were to show what, in essence, I'm showing you S of 4 here, 2 times 4 squared, minus 5 times 4, plus 4D, and we already know is going to be 52. We already know that. All right, so 4 plus H squared is 16. 4 squared is 16. Plus 2 times 4 times H, 8H. Plus H squared. So right here, when we distribute the 2, we get 32 plus 16H. When we distribute the 2, we get 32 plus 16H plus 2H squared. Now I'm going to distribute the negative 5. Minus 20 minus 5H. Then I have plus 40, and we know this is 52. So 32 from here plus 16H plus 2H squared. We distributed the negative 5, negative 20 minus 5H plus 40 minus 52. $32 minus 20, 40 minus 52. They add up to 0. They add up to 0. They cancel each other. So we end up with 2H squared plus 16 minus 5, 11H. So the numerator simplifies to 2H squared plus 11H. And we factor out the H. So we have 2H plus 11 in the numerator. When we take a limit as H approaches 0, that means we are going to replace the H with 0 here. We get 11, and as always, we have to write the units, 11 feet per second. I hope you see there are many, many more algebraic steps than calculus step. When you evaluate at the last moment the limit, this is your calculus step with the asterisk next to it. This definition is a calculus step. Everything in between is your algebraic technique. Here's the next one. Suppose that the ball is dropped from the upper observation deck of the CN tower 450 meters above the ground. S equals F of t equals 4.9 t squared. That's the formula we're going to use. What is the velocity of the ball after 5 seconds? How fast, again, the velocity is the ball traveling when it hits the ground? Notice we want the velocity in both cases And in both cases, we are looking at a specific time, one time, where the first case, the time is given. The second one, we have to figure out what time it is, and we have to calculate the velocity. And in both cases, we need to use differentiation, which is this formula. So rather than using A as a 5 here, I'm going to use A just the way it's given, so it will make life easier when I go to part B. And A is 5, whatever the A that I find here, I can plug it in. In essence, we are finding the derivative in general. So let's find the instantaneous velocity with A being simply A. So I'm not going to replace the A with 5. Because if I do, then in part B, whenever I find the A, the time it hits the ground, I have to do this again from the scratch. So we're going to keep it as A plus H, and we're going to plug it into this. We are going to replace the T with A plus H and then with A. And we've already seen how to square things up. So let's just quickly write it again. This is A squared plus 2AH plus H squared. So you notice this has a 4.9 in front of it. This has a 4.9 in front of it. So if I factor out the 4.9, I get this one minus A squared. So I'm going to factor these two pieces. The 4.9 comes out. And now the good thing is that I can drop the A squared and negative A squared. Now, remember, it is the 0 in the denominator that creates a problem. And we notice this expression in parentheses, we can take the H out. If I get the H out, I'm left with 2A plus H inside. And now, if I drop the H, I'm left with everything else, and I can plug in H equal to 0. So now, if I put it here, I get simply 2A times 4.9, which is 9.88. So I got the velocity after A seconds. That's the meaning of it. And that makes it really interesting to finish off the job. So what is this? The instantaneous velocity at A seconds. As long as I have the time, I can come up with the velocity. I don't have to go through the same process again and again. So for part A, I'm going to use 5. So I'm going to plug in 5 here for part A. 9.8 times 5 gives me 49 meters per second. But for part B, first I have to figure out what is a T. It says how fast is the ball traveling when it hits the ground. Remember, it's 450 meters above the ground, and it covers this distance of 4.9 T squared. So I got to set this equal to 450 to find the T. So T squared is 450 divided by 4.9 using a calculator. So 450 divided by 4.9 gives me this 91.837. And the T is the square root of that. And the square root of this number, maybe with only one decimal. It depends. You want to follow how many decimals they ask you. It's about 9.6. And now in this formula, I plug in A equals 9.6. And that gives me the velocity of the ball when it hits the ground. So 9.6 and 9.8, their product is 94.08 meters per second. That is the speed by which the ball will hit the ground.